Hello, fourth grade. Today we're going to talk about common factors. And if you remember, factors are two numbers that multiply together to equal a product. So think about the number, let's say 8. Okay, before we solve this problem, what do you think the biggest factor of 8 would be? The largest? Yes, okay, so if you said 8, that would be correct. So the largest factor of a number is itself, and the smallest multiple of a number is also itself. Because if I'm talking about factors of 8, I'm talking about 1. 1 is a factor of every number. 2, 4, and 8. Those are the factors of 8. So the 8 is the largest. And then if I were to say the multiples of 8, well, 8 times 1 is 8. And then 8 times 2 is 16, etc. So the smallest multiple of a number is itself, always, okay? So now let's go over this problem. Sophia and Alex are putting 12 red lizard keychains and 18 blue lizard keychains into boxes. Each box must have the same number of keychains. Each box must have only one color of keychains. All the keychains should be used. How many keychains could they put in each box? Okay. So what they don't tell you is how many boxes. So that is something that we can make up ourselves, okay? So the first thing I would say is, we could just put each lizard in its own box, right? And so I'm not going to make a box around every lizard, but that could work. And so then that would just be 12 plus 18, which would be 30. Okay, so that is one option. It could be 30 boxes. Okay, and then another option could be that you put 2 in a box together, right? Let's try that. So we got that. This one goes with this one, this 2, okay? So then we got these, this, and this, and this. Okay, so now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now we have 15 boxes, and there can be 2 in each box. Okay, so far we have done 1 in each box and 2 in each box. Now, what do you think? Do you think that we could do 3 in each box and make sure that every single lizard is used? Let's try it. We got 3 here, another 3, another 3. Here we go. Okay, cool. 3, 3. Oh, there we go. Okay, now we have 3 in each box. So that is also an option, okay? And then let's see, what if we decided to try to put 4 in each box? Do you think that would work? We've got 18 blue, 12 red. Think for a second, talk to a partner for a moment. So if you thought that you could not put 4 in each box, you would be correct. So for the 12, yes, you could put 4 in each box, okay? We got these, and we got these. But 4 is not a factor of 18. And so for that reason, you're going to have some lizards left over, okay? So now we have 2 lizards left over, so that is not an option. And that's because 4 is not a common factor, a factor that 12 and 18 share. So that is not an option, 4, okay? And then what do you think about 5? Could I put 5 in each box? I have 18 and I have 12. 5 without any going over? So if you thought that we can't, you would be correct, because 5 is not a common factor, is not even a factor of 18 or 12. So we're going to have some left over, or we're not going to have enough. What about 6? What do we think about 6? Let's try it. We have, this is 6 here, and then this is another 6, and this is another 6, okay? And then here we have 6, and then here we have 6. So yeah, we could also put 6 in each box. So those are the options, okay? And so when we're talking about common factors, we are talking about factors that both numbers have in common. So let's go over all of the options that we just talked about, okay? We said we could put 6 in a box for all of the red, right? And that's 6 times 2 is 12. We said that we could put 3 in a box, and that would be 4 boxes for the red, okay? We said that we could put 2 in a box, and that would be 6 boxes. Get out of here. 12. And then we also said we could put 1 in a box, okay? And that would be 12 boxes. So these are all of the factors of 12 we got. And then when you list factors, you want to put them in ascending order. So starting at the smallest and going up. Okay? And then if we talk about 18 and what the options were for the blue, we had 1 times 18. We had 2 times 9 boxes, okay? We had 3 times 6, okay? And then we had 6 times 3. So like this is just 6 lizards in 3 boxes, and this is 3 lizards in 6 boxes, okay? So these are all of the factors of 18. We have 1, 2, 3, 6. Well, we're and 9. Just kidding. 9 and 18. Okay, those are all the factors of 18. And then when we talk about which ones they have in common, that would be just looking at them and circling which ones are the same. 4 is not a common factor, so we don't circle that. But 6 is. So then those are all of the common factors. 1, 2, 3, and 6 between 12 and 18. Now the reason that you need to know this is for a lot of different reasons, but definitely so that you can reduce fractions when you're simplifying them, and adding fractions as well, and finding, you'll also need to know this for finding different combinations of things, just like we did here. And then we're gonna go over one more thing. So let's say that we're trying to find the common factors between 6 and 8, okay? First, we'll start with 6. We know 6 is 1 times 6. We know 6 is divisible by 2 because it's even. Same thing here. You don't have to put both of those out, honestly. And then 6 times 1. Yeah, these are all of the factors of 6. So it just would be 1, 2, 3, and 6. And then for 8, it would be 1 times 8, and it would be 2 times 4, and that is it. I could write the other iterations of them, but it's the same thing. So the factors of 8 would be 1, 2, 4, and 8. And then all we have to do when we find the common factors between them is we just circle the ones that they have in common. And so the only common factors between 6 and 8 are 1 and 2. So let's do a little bit of a trickier one. So we'll have to find the common factors between 24 and 36. Okay, these are getting a little bigger, but we can do it. Obviously 1 times 24, right? It's even, so we know that we can divide it by 2 and get a whole number as a result. we can add 2 plus 4, which is 6. That's a multiple of 3. So 3 is a factor of 4, 24 rather. 4 rather, yes, because if you divide 24 by 2, you get 12, and then 12 is an even number, and if you divide 12 again by 2, you get 6, and that's the same thing as dividing 24 by 4, just dividing by 2 twice. So 6 and 4 are factors, and then we already know 8, so we don't have to write it again. It's not a multiple of 7. So those are going to be all of the factors of 24. Oh, well, and 12, but we already put 2 and 12. For 36, we're going to do 1 times 36. It's even, so it's divisible by 2, and that would be 18. 3 plus 6 is 9, and so 9 is a multiple of 3, so it is divisible by 3, and that would be times 12. And then 36 is also divisible by 4, because if you divide it by 2, you get 18, which is even, and divide that again by 2, that's 9. So it would be 4 times 9, and then it's not divisible by 5. It is divisible by 6, because it's divisible by both 2 and 3. It's not divisible by 7 or 8. We already did 9. Okay, these are all of the factors. So then we list them in ascending order. 1, 2, 3, 4, 6, 8, 12, 24. Oops. And then this one would be 1, 2, 3, 4, 6, 9, 12, 18, 36. Okay. It's a lot of factors. So now we just go circle what they have in common. They have a lot of common factors. And 12. Okay, so those are all of the common factors between 36 and 24. When you find factors, you're always making sure that you know your divisibility rules so you can find out the factors. Otherwise, it's going to take you a really long time guessing and checking. So please reference your divisibility rules. I'm going to give you one more problem, and we'll see how you do with it. Let's see if I can do it. All right, I'm going to have to write it out. So we have... You can pause it for a moment while I write this. Can hear the dog barking in the background. 24 red roses and 32 yellow roses. Okay. So they want to make identical bouquets. There's like a dog fight happening. They want to make identical bouquets. Okay, each bouquet has to have all, at least, not all, at least one rose of each color. Okay. What is the greatest number? So this is us finding the greatest common factor, which is something you'll do in 5th grade and 6th grade, 7th grade. What is the greatest number of bouquets? Sorry. They can make. And how many roses of each color will be in the bouquet? And how many roses of each color will be in each bouquet? Okay. So, So sorry, that was a long question. Okay, so the way that you can do this without, just guessing and checking is you can just find the common factors of 24 and 32. So we already know 24 because we just did it. So we'll do 24. We got 1, 2, 3, 4, 6, 12, 8, 12, 24. Okay. And then for 32 yellow roses, we have 1, 2, not divisible by 3, yes divisible by 4, not divisible by 5, not divisible by 6 or 7, but divisible by 8, and divisible by 16, and I think that's it. Yeah. And then obviously divisible by 32. Okay. So then we have to find the greatest common factor. So we're looking, okay, these are common, there's still a greater one, there's still a greater one. So now we know that we could have 8 bouquets, okay? So that's how many bouquets we'll have. And then if you look, you just ask yourself, for the 24 red roses, right? There's what times 8 equals 24? So it's 3. So then we have 8 bouquets, right? We've got 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3, 2, 3. One, 2, 3, 4, 5, 6, 7, 8. Cool. So we got all of the red roses covered, and then we've got 32 yellow roses, okay? So what number times 8 is 32? If you said 4, you would be correct. So then we put, okay, 1, 2, 3, 4. That's a lovely bouquet. Okay, so that is the answer. There's 8 bouquets, there's 4 yellow roses in each, and 3 red roses in each. So for homework, you're gonna have a question like this, and just remember, you're gonna list the factors of each one. You can draw a picture if that helps you, and if you get really stuck, try the best you can. And if you still are stuck, then bring it to school, and Miss Rayor and I will help you. Hope you enjoyed that lesson. Sorry it was really, really long. Have a great day.